Recording.
Hello, future people. Welcome to Karuta.
Yeah, today you were very happy, Marin. You never do that.
Well, that is true, but also, I don't know, it's been a good week, I think. Um, so today, for the sake of recording, um, we need to fix this function because it works on addresses, but we now have things that are not addresses, namely integers, and they don't work with this instruction yet. So that's what we're doing. Um, Yeah, get value is basically just unify, and unify does a bunch of stuff. Whole bunch of stuff.
Wait. We are talking about making unification work for something that are different in addresses, right?
Yeah, because right now, everything is an address, logically. Like, even though it may not actually have this address tag, a reference is basically a pointer, and a functor is also basically a pointer. So, yeah, they have addresses, but a constant does not have an address, it's just a number, right?
Yeah, yeah, that's true. That is true. Yeah, but I remember the problem is not in here. The problem is before, right?
Yeah, the problem actually is that,
Yeah, these arguments
like,
here are being interpreted as addresses, but they are actually raw numbers.
yeah, they're pure integers. The issue is when we do get value, which is just unify, like we do this call, right? Which means we need to do this destructuring here, which was fine before but isn't anymore. That's the problem.
Yeah.
That's the freaking problem.
Yeah, but I have a question.
Yeah.
Um, why how are we getting there, right? Because do we have references or no, yeah, go back to the place that you were before.
Well, back to the place that I was before. You mean here?
Yeah, do we have references or structures in there?
Yeah, this is something that came from a register, right?
Yes.
And it will be either a reference or a structure, and before that's all it could be, but now it can also be a constant,
Wait,
which
are we
does not
going
have
to
an
line
address.
598? We are not, right?
598. We are now actually.
Wait, can you run the what are we running? Can you show the example again?
We're running plus, and plus is basically just this, right?
No, this is not what we are running, right?
It is actually.
Are you sure about that? Yeah, we're not running this at
Uh,
all. We're running another example that allows us to use integer literal, right?
but this has plus. Yeah, but this has an integer literal here.
No, but that's fine. I'm talking about integer, the primitive. We're talking about is integer.
We're talking about is integer.
Yeah, I believe maybe you restored the example, and now the example of plus is not using built-in primitive.
Hmm. Yeah, it isn't.
Yeah, so we're not gonna hit the problem.
No, but we are, because the problem is not with the new primitive, it's actually with, what do I need to do? Is it this? Um, no, that works.
No, man. The problem is when you use the int primitive.
The int primitive.
Yeah, we made an is integer thingy, right?
Oh, right, so this actually has the other problem, because, yeah, if we try to tail call this thing, it doesn't work.
Yeah, that's the problem. We already made it work before in the code generation. Like the entire last session was all about that. The current problem is because the evaluator doesn't know how to treat it. and that happens because of the unification. But my question is,
Why
how are
would
we
it happen?
getting? Go on.
Why would it though? Because like, let's see. If we do, what is it? If
No,
we
go to
do,
plus and put the integer primitive in there.
okay, let's
Somewhere.
say is integer.
No, that's not
Okay.
how that works. It's int, right? So just int. No, int.
Uh,
Not is int. Int.
oh, right, that's correct. Actually, we didn't do this.
Yeah. So this is what it breaks, right?
Parametric failed on the code gen actually.
Okay, that's new. I was 100% sure we made it to go to the evaluator. That's not
Uh,
good.
335.
Yeah, I remember
Pa-pa-pa-pa.
this. Oh, I remember. The bug of the tail call, it's this one. The corner case being the bug instruction. This is a different thing. So then we need to make the int not be tail call. And I remember how you did it. You added the int on line 2, and then you called net as the tail call.
Uh, yeah, that doesn't quite work. We need to do something like, I don't know.
No, that will work. What I said that you used before, that will work. Just put net
Uh,
0 dot on line 1, and then on the successor, you ask if int n is an int before calling net.
yeah,
That
that's not gonna run, but okay.
What do you mean that's gonna run?
Because if the encoding we are using, only the base case is a real int, otherwise it isn't. So it's not gonna run the computation, although it will run the instruction, and yeah, unreachable get structure.
Oh, I
That's
see.
the
It's
problem.
because n is a potentially successor. That's the problem.
Unreachable get structure, that means get structure.
Yeah, it's 128.
Um, right, because it doesn't handle constants yet.
So let's add constants to it.
Let's see. We do a get structure, and then
The ref cell on it.
hello. Who is it? Hello, Willy.
Hello. Hello, hello.
Yeah, it's amazing. I have an extra monitor now.
Yeah, no. I have no idea how you lived your life before that, but okay. Uh,
Uh, okay, so we're doing this, um, which basically says, okay, the value in this register must be a structure. In order to deal with that, we do a deref cell on the get register, and deref cell actually works with constants now.
yes, it does.
And for some reason, oh, I think I know what it is. I switched branches before. Yeah, I switched the branch after opening the editor, so we didn't do the new DRAM. So get structure here. Yeah, so deref cell actually does work for constants now, so that's fine.
Yeah, we
The
need now to do a
problem
pattern matching there.
is that, yeah, we're not dealing with this, but
I already forgot. What are the semantics of get structure again?
with the value in the register, which is the second argument to the instruction, must unify with the functor prototype, which is the first argument. So basically, it needs to match the name and the arity, the label and
Wait,
the arity.
but if that's the case, we're
That
using
means,
constants in a sense of the book, right? So the book should know how to handle this.
well, it needs to just fail in this case.
Yeah, but I think I should grab the book to see what the heck's going on. Because I just remembered we are using the book as a reference for constants. Why should this just fail though?
Because a number shouldn't unify with a functor of any kind.
That makes sense.
Fail
Oh,
with
wait. You changed the
corrupt.
128. 128 is not correct.
What do you mean? Oh, right. Constant.
Yeah. In the meantime, let me actually check that get structure in the book does what we are thinking it does.
Mm,
Oh, there is a function called get constant. Oh, we implemented that already. I'm stupid. Well, in the book, the catch-all is a fail true. But I don't think we should do that, right?
why?
Because when we add another thing, another type of
They should.
cell, we want
It
it
should
to
also.
fail.
Well, no, it should fail the unification. It's defined actually because you're trying to do a get structure, unifying something that's not a functor with a functor. So that should always
No,
fail.
no, no. What I'm saying is that I rather do 128 every time we have a new built-in, rather than make it happen silently via the catch-all.
Why?
Because there may be a situation where we have to think about it. The constant one is not one of them because it always fails. But in the future, we may make a built-in that requires special behavior, and the catch-all will make it worse, the experience to find that.
Can you imagine such a situation, Lemos?
Yes, I can imagine many situations already in my life where I did a catch-all and I regret it.
No, 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 not the catch-all. Can you imagine a situation where this catch-all is not correct for this particular function?
It's not a, well, answering your question directly, no, I can't. But I would rather do it because I rather be aware that something needs to change. Like we just did, for example. We had to think about it. You added 127, for example, just because we touched this function, right? So the act of going here made you think more about it, and we only went here because of the fail with.
But they should have been here from the beginning, though.
No, yes, I agree, but well, that's my opinion. My opinion is that catch-alls are really like less resource. If you don't agree, we can make it the catch-all be fail through.
I think it doesn't make sense to do this for this particular function because, like, semantically, like if you unify if you're trying to unify a value with a functor, it should only succeed if it's a reference or another functor that matches the structure. Like, there's no situation other than those two cases where it should succeed.
I don't know the answer to that question because I don't know what we're going to be doing in the future. So I rather
It's
keep
not
it
a
as it
question,
is.
Lemos.
Yes, it is. You asked it. Can you imagine a situation that will happen? I can't right now, but I'm betting on the future. If you are saying that we're never gonna do that, well, say as you might, but yeah, you can make the catch-all be the fail true. That's fine. I'm just expressing my opinion because I wouldn't do it.
Okay. Okay.
No, execute the code. Execute the example. We fixed it. So now we're gonna fail somewhere else. Ah, great. We don't know where. Okay, so somewhere, somewhere,
mm,
somewhere.
over the rainbow.
I think we need to create a smaller program. Let's create a
Uh,
test.karuta and let's make a function that identifies an integer. I think that's easier. And then we use some sort of um, dummy functions to call integer not in tail call position.
okay. So Hmm. Actually, here's a problem. I don't think this will work quite well because, like, I don't. I we implemented this instruction to just check if the value is an integer, right? We don't really bind a free variable if we pass it as an argument,
Oh yeah.
which we probably shouldn't, but
No, man. Here's what we're gonna do. X should be not, and then we're gonna use the same naturals that we were using before, and the query is gonna pass 0. But not 0 needs to come after the. Ah, no, that's a problem. Ta 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 ta. Yeah, something like that. Exactly, exactly. It's something like that.
does this work? This won't work, right?
This won't work. We're not running the same program.
Main. Hello, Magetta.
Hello, Magetta.
Yeah, this doesn't parse, which means we need this, and now this should work. Exception not found. Amazing.
Yeah, the error messages are trash. Okay, but what are we doing here? X doesn't exist.
Oh, that's true. Net.
That's terrible. Wait, what?
That is correct, actually.
No, but I'm confused. I'm extremely confused, actually.
Why?
Because that means that int is working already.
Well, it should be. If we do, I don't know, whatever, they should fail, and we should loop forever.
Go for it. No, loop forever, segmentation fault.
Actually, let's try this. Why not? Yeah, that's what I expected, actually.
Wait, I'm still extremely confused because oh, okay, so we need to make an example that the that what is this why is this different from the plus? Why is the plus breaking then?
Why is the plus breaking?
Oh, it's because in the plus we are trying to unify the n that is coming from the net with the n that is in the int.
Yeah, this is never gonna pass.
Yeah, that's never gonna pass, but that's what we were trying to do, right? We're
Not
trying to
originally,
unify
but
them.
yeah.
No, but that's we need an example that works like that because we're not hitting the problem in the new example.
That's because this is not the problem. The problem is we're doing a get structure on a register, which means what do we need to do? We need to do, let's try two. That's not it. Get structure. Get structure is submitted when we're not in a query.
Wait, what
We're
did you
not in a
change that is now
query.
breaking?
What did I change that's now I changed the this to number two instead of a variable.
Well, but a number two will hit segmentation fault because we do not find an answer to that.
Uh, yeah, we need
That
to do.
man, we need an okay. That's not as simple as I thought. We need a more contrived example to make this.
Let's see. We emit. Uh, we emit a get structure when we have a functor in an argument position, and the register contains a number. I think that's it, right?
I'm kind of lost on which track are you following because how are you getting the problem? What's the problem you're trying to solve?
Um, well, we need to hit that problem in the unify, no?
Well, that's as well, but again, I'm trying to make the example simpler because then we can put prints in the places that well, we don't have great error messages for the compiler development. So that's why I wanted a simpler example.
And that's why I'm looking at this code, because I want to see what's the simplest example that hits the error case we care about.
Ah, okay. That's okay. Let me try to help you. So you're trying to
So
reach the get structure.
get structure is the func in the case where it's not in a query,
Hello, Maggot.
Hello.
which means we need to do, yeah, we need to do a predicate call where the argument needs to be a number, but the expected argument needs to be a functor. That's what we need. So test. So the argument needs to be a number. The expected one needs to be a functor.
Swap
So
the two lines. Yeah.
yeah, this should break, but it didn't.
No, well, it did, but it did for probably. Oh,
Oh,
it's
it's
because
because
of
of
the
this. We should
yeah,
get rid of this.
yeah, yeah. I think so.
Nope.
No, didn't. Oh, the order matters. This is prologue, right? So the zero will never be reached ever.
What do you mean? It should be. Because it's going to try this
Oh,
and it's gonna fail and it's going to
actually,
try this.
that's true. Remove the int, whatever, just for us to confirm that this program works. Yeah, run it, run that.
We don't need this anymore. It
Well,
does.
I wanted to have the true, like the exact same program before the we introduced the bug. Go for it. Okay.
It
Now we
works.
introduce the bug.
Now we introduce the bug. But hmm,
What?
we need to do
Yeah, just add the int back. The int before the true, and put whatever there.
int. That's gonna loop, no? That's not what we want.
That's gonna loop. Why?
Because it's going to try this, it's gonna fail. It's going to try this, but it's going to do int whatever, which is also gonna fail. So it's going to try, well, this again, I guess.
Okay.
Hmm. Like int whatever. Yeah, it just loops.
No, but we don't know that. That's kind of the thing. We don't know if this segmentation fault is because it's looping or because of something else. No. Oh, it is
Oh,
not
it's
because
actually
it's
the int.
looping.
Oh, it's actually the is integer. That's interesting.
Yeah. Yeah. So this is eval, right? So just let's just go there.
Evaluator.
What are we doing? We are calling a function called this integer and incrementing the program. Go there. That
We go
makes
there after.
perfect sense. We are doing a match, and that's definitely not a constant because it's a whatever, so that's a functor of arity 0, which means that the match on line 518 is going to true, right? Man, isn't this
Uh,
swapped the order?
what do you mean?
The name of the function is integer. Oh, but we are just changing the fail. Okay, that makes sense.
Yeah, this is the fail. So we should not fail if it's an integer.
We should not fail if it's the integer. I agree. Okay, but then okay, we need more prints. We need more prints.
Hmm. Hmm. Hmm.
That's hella weird, man. Yeah, we're not reaching there because the pattern matching on the predicate is not is on going to line 2 100%. Yeah.
Okay, so first of all, the code is the output constant. We call net, and then we halt. That's the query. Then we have proceed. This is probably the true, I imagine. Then we have the prime else, and this is definitely the net. We do a get structure. We do a get structure. Yeah, no, this is working actually.
No, yeah, the get structure is on the successor, so it's fine.
No, this is what was broken actually, and this is working now. Like, that's where we were halt. Yeah, that's where we were in the unreachable get structure before, so that's okay.
But that doesn't make sense. You're doing get structure with the successor. Why is that a problem? Ah, yeah, no, why
Because
is that a
cell
problem?
0 was a constant, you see?
Ah, okay, I see. I see what you're saying.
Hmm, let's... Oh, wow, the chat is kinda messed up on my other monitor, but okay. Okay, let's see.
Okay, we are
I
fail.
still,
Go on.
I still think we don't need these actually.
No, if you think that's fine, that's fine. But if we ever introduce a feature that you're gonna be wasting hours because this is failing ghost in a ghostly manner, I will say I told you. I'm telling you right now.
Look, can you imagine logically a situation where something that's neither a reference nor a structure can unify with a
I
structure?
have no idea what we're gonna make, brother. I have no
No,
idea of
no,
the future at all.
no, no. I'm talking about semantics of simple immutable data structures. Is there ever going to be a situation where something that's not a variable and not a structure can be a structure?
I have no idea what we're gonna introduce in the future for this language. I have no idea. Right now, the answer is an obvious no. I cannot imagine. Go for it. Follow your
Mm,
heart, Marinho. Come on, man.
there is one thing actually. If we ever need to make an object which is a proxy to something on a physical database on disk that behaves like a structure, then yeah, we actually would need to unify it with a structure.
Yeah, I have no idea of what we're gonna do, especially when the database phase comes. So it's up to you.
Hmm. Yeah, let's leave it this. Let's leave this here for now. Okay, so this is working now. What was the other problem?
No,
Um,
no, this is not working.
it is.
No, it is not.
Look,
Um, Man, now I'm pissed because we don't have the example that made the get value break.
Is integer. The print is before the execution, right?
Yes.
Okay. Let's see. Internal registers. P is 18, which is deallocate. Which is deallocate. Is the deallocate breaking?
Wait a moment. The is integer worked?
I mean, it printed.
No, but we have a man. This is wrong because we have the fucking whatever there, right? Yeah, it is a structure. We're trying to ask if a functor is an integer.
And it should fail.
Yeah, but instead of
Um, plus, not
are we
plus.
running
It's a
plus or
test.
test? Okay.
No, we're running test. Okay, so this should fail. Let's see. Okay, this is gonna be really dumb, but this should succeed actually, right?
Well, actually, that's a good question. I have no idea because, well, given the semantics that I understand, it will not
Okay,
succeed.
okay, we go to the debug, put structure, put
Ah, I
value,
know what you're
is
doing.
integer, that fails. Then you go to the trust me and
Ah,
this should work.
okay. So I take that back. That actually makes total sense. So the integer is working as intended. It's saying that whatever is not an integer.
Yeah.
Okay, here's the situation. We need to have some unification going on. We need a get value or a unify value of some sort. Because I think that's where we're gonna hit the fucking unification problem.
Okay, so something like, I don't know, like this, I suppose.
Like this. I I don't follow yet. I still don't follow.
Right, so basically, this is going to succeed, but it's going to try this first, right?
Yeah.
So
You're not calling integer here.
that's doesn't matter. We are concerned with the unification with the zero actually. That's the problem.
Ah, I guess you're right. We also care about the identification with the yes, that's true.
Okay, so
This works.
this worked, but we didn't call unify.
Well, we didn't call unify because the pattern matching of the functor the successor saved us, right?
That is true. So we need to do something like, I don't know.
No, we need to unify a number with another thing. Yeah, that.
That actually works as
No,
well.
but that is going to the single case of the constant now. That is checking L is different than R. Yes, now we're talking.
That
And it
halts.
works. So
That
we need
halts because we're doing a unify constant here, which means actually we need to flip those. We need to do a variable here and a number here, right?
I don't know if that's going to make any difference, but let's try. It doesn't.
That also halts.
Yeah.
Unify variable. Oh, unify variable actually doesn't call unify. That's the problem.
Now we need unify value or get value.
Unify value or get value.
Yeah.
Yeah, get value is unify.
And unify value calls unify as far as I remember. Yeah. Bug on default.
It does. It does if we are in read mode and we get a reference.
Man, but that's hard. We are trying to make an example that will make the thing fail, and it doesn't fail. Well, the plus is definitely failing, so I'm fine for that.
Let's just do something like, I don't know, whatever, 0, 0, right?
Sure.
And we say whatever holds whenever we have a successor of n a and b, a and a actually, right?
Okay,
Because
let's
the
try
first
that.
a is, yeah, the first a should be a unified variable, but the second one should be a unified value.
Yeah, okay, let's try that. There we go. Okay, okay, that's good. That will force us. Yeah, that's not a reference.
That's not a
183.
reference
That's not a reference because that's a constant.
because it's a constant, yes.
So yeah, yeah. In here it's easy to fix, right? We just. Ooh. No, actually it's not easy to fix because if you have a constant, we need to call unify. But unify doesn't know how to deal with things that are not addresses, which is exactly the problem that we want to fix, right?
Mm-hmm.
Okay, so we made it. This is an example that forces our hand. Cool. Cool, cool, cool. Okay, so now let's discuss. How the fuck are we gonna fix that?
Hmm. Hmm. That's an excellent question, Lemos.
Man, I think the book must have some sort of solution to this problem. Because the
It
book
probably
has
does.
constants. Oh, it has a unify constant. Do we have unify? We already implemented unify constant, right?
That's when you have a constant inside of a functor that's being matched to an argument, which is the opposite of our case, actually.
Okay. But there must be a solution to this one. There must be.
Mm, let's see. Um, not unify.
Is Magetta alive?
And yes,
It doesn't. You don't sound alive, friend. Are you
You
okay?
sound.
fix my cables.
Sorry.
I can barely hear him.
Also, we're
I'm
recording.
fixing my cables.
Oh, your cables. Okay.
And it's a rat's nest below my feet. One day I'll die of like a shock, electrocuted, something like that.
Oh,
Okay.
yeah. You should avoid that.
Yeah, please avoid
If
that.
possible.
Okay, so let's continue our surgery here.
Let's see. Memory layout. Unify. Not this. Deref.
What are you looking
Bind.
for?
Unify value.
No value. It's page. I can tell you the page. It's page 119 of the book.
Of the book, not the PDF,
Oh, the
right?
PDF. Sorry, the PDF. PDF.
Here?
Yeah, mine version
Oh,
here,
wait. It's
119.
actually here.
Yeah. Yeah, this doesn't treat the constants at all. We need to care if it's a reference or not because of, well, because of the implementation detail. But in here, it doesn't matter.
Case mode of read, we do one thing, heap, we do another. Yeah.
Man, but
Yeah, I
then
think.
his
I think.
unify is fucked then because we know his unify,
Hmm.
and his
Yeah,
unify treats everything as addresses.
yeah, I think. I think the easiest, probably the most principled way of doing things is to just say Okay, Unify actually works on cells, not addresses.
Man, but that's gonna complicate the entire shit.
Why?
Because we have a lot of stuff that is based upon the fact that we had addresses. For example, the PDL management. Everything that we do, well, not everything, but a lot of things that we do in the unify function is based upon this assertion that we have prepared the PDL to do shit, and in fact, inside the while loop of the book's version, we actually use the PDL that we prepared before. And the only reason this works is because the arguments are addresses. Magueta, Magueta, Marinho, are you saying something?
Nope.
Okay.
I'm thinking here for a moment. Hmm.
Like if you scroll down even more, there is a portion. Yeah, you see there, we do more PDL stuff. And if you scroll down, yeah, that's actually it. We do PDL in the beginning and in the middle. And this only works because we have addresses in the beginning.
This only works because we have addresses.
Yeah, 158, 159, 177, 178, 152, 153. All of those things are relying on the fact that A1 and A2 are addresses, man.
Hmm. Okay, let's see. Um, okay, so first off, we push the two addresses. We assume they are addresses
Yeah,
to the PDL. And then whenever we push more stuff to the PDL, we also push them as addresses.
yeah,
When we pop, we assume it's an address because we only push addresses, so that makes sense.
yeah,
But then we do derefs on the addresses.
yeah.
We can just make the PDL accept cells instead of addresses, which is trivial because it's memory. And then, where are we using the PDL? It's
No,
just
no,
here,
no, no,
right?
no. The PDL already works with cells, man. Address is just a type of cell.
Unify, unify. Yeah, we don't touch the PDL anywhere else, only here.
No, 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 yeah. Like, the PDL already accepts cells, but the only cell that we usually push to the PDL are addresses. That's fine. That's fine. That's actually fine. We need to do some sort of pre-processing on the cells, I think. Like, we need to
Mhm.
grab, instead of pattern matching the reference on the unify value, and then extracting the numbers out of the reference, we need to pass the references to it.
Yeah, we need to make it work on cells,
Yeah, but this
basically.
this this causes another problem because sometimes we pass registers as arguments, and
No, we
registers only
don't.
go. Are you sure? Can you scroll down?
Unify. Actually, not unify.
No,
It's
no, there. Scroll down there, please. Actually, there.
here.
Yeah. Yeah, we are totally doing that. So 194. We're totally doing that.
Okay, we do a get register. We could just say, okay, get register. Instead of the address here, we just pass the result of get register here, and then instead of s register, we make a reference with the s register.
Ooh, I see what you're saying. But let's continue that thought process. So go to unify. Instead of receiving A1 and A2 being addresses, we're going to receive cells, right? My understanding is that the first thing we're going to do is to pattern match on it.
No, the first thing we have to do is actually push them to the PDL.
Push them to the PDL.
As we are doing, except instead of wrapping it in an address, we just push it as it is.
Okay, you know what? Let's just do it. Let's just break it. So let's start by changing the type of 150.
Okay, so this needs to be a cell.t, right?
Yeah.
And
Yeah, now 152 is fucked, but just remove the addresses. And there we go. But now 158 and 159 will be fucked.
yeah, we need to do. Oh, these are not addresses, so it's just P1 and P2. This needs to be dref cell, and this also needs to be dref cell.
Man, but I'm a little scared because every time we try to use the ref cell in a new use case, we have to do some shenanigans because the previous cases didn't account for this use case. So
This should be fine.
I'm a
The
little
real
scared.
problem is no. The real problem is when we have a thing which is
Addresses?
direct address. It's a functor. It's this. Otherwise, it's the candidate. If we have like when we introduced the new structure thingy here, right? Before they only existed in memory, but then we said, okay, no, it's actually okay to put them in registers because the book actually introduces that in optimization, right?
Uh-huh.
And then this was breaking because suddenly, okay, cell is not always a reference; it can also be one of these, right? But this should work, I think, for this use case.
Okay, but
Um, except here
except
we can't just. Okay, if they are different, we match,
we just
otherwise
go
we
to the
loop.
next iteration, right? Yeah, we just go to the next iteration.
Yeah, if they are equal, we loop, which is fine. If they are different, then we do the match. We don't need those gets anymore,
We just match them
actually.
directly, right? D1 and D2.
Yeah.
Okay. The bind is
If I
fucked. But here's the kicker: is I think bind and trail. Oh no, trail actually is used somewhere else. Fuck.
D1 and D2,
Check if bind is used somewhere else. Because if bind is being used only here, we don't care. Or it's
it's
not.
used in get structure as well.
Okay, so now what, Sherlock?
And input value, actually.
Okay, but in our use case there, we're not using. Oh yeah, bind is assuming to be using address number integers.
Mm, it looks at the tags. Wait, it derefs and looks at the tags. We can just make it work on cells directly as well.
But that's gonna break the other places, brother.
Well, yeah.
No, okay then. So be it.
Hmm. uh, let T1 be get store with functor structure, otherwise as is. Um, can't we just do T1 is a cell and T2 is a cell and get rid of these?
No.
No, we cannot. If T1 is a reference, and either T2 is not a reference or, and then we need to compare addresses.
Yeah. Nah, it's fucked.
This can be match T1, T2
Well, I'm glad OCaml has
with.
our pattern because I think we're gonna have to use it now. I think it's better you undo the changes and let's see what each T1 and T2 were before the deletion, and then we do this matching.
They were just gets basically.
Yeah, but they were gets that extract stuff. But in our
No, if
case,
it's
we already have
no,
the
it's because if
stuff.
it's yeah, because if this is a functor, it needs to actually be a structure basically. But otherwise, it's literally just a get.
I I see. Okay, interesting. How are we gonna match T1 and T2 now?
Match T1, T2 with well, if T1 is a reference with address of 1.
I think we need parentheses, and yeah, we're gonna have to do a bunch of ors in here. So there's also structure. No, 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 don't do it like that. We need to do ors inside the tuple, friend. Right?
Or is inside of the tuple.
Yeah, because we have reference A1, address A1, structure A1, right?
Yeah, we have an and then we have this other condition here. So either this is not a reference, T2 must not be a reference, or if it is a reference, A1 must be less than A2.
Okay, so this is a reference.
Hmm,
Okay, that's gonna be annoying as fuck. Because now we need a no, we need a guard there. So when
when
A2
A2
smaller than A1, then you do
or
that computer shit there.
no, but we also need to handle the case where T2 is not a reference. This also
Okay,
must
so
hit this
or
one.
reference A1 and then catch all for the true for the second guy.
Then we do
Then
this.
we do that. And then um, else. So catch all, no, catch all there,
Else
catch all
is
there.
yeah. Else. Oops. Yeah, the problem now is okay, why is this complaining?
I think you may need parentheses because of the guard. I'm not sure.
That makes sense actually.
This is still broken.
After unclosed, but
Yeah, something is fucked. You need parentheses on there as well, maybe?
nope.
Yeah,
Hmm.
that's very fucked. Okay, so how do you do OR patterns with the guard OCaml? How do you do OR patterns with a guard? That's a very good question. Can we make a OR pattern that contains a guard? We should, right?
I mean, it would make sense if we could.
Okay, according to my search here, yeah, we don't even need the parentheses according to this. Yeah, yeah, yeah. There is an extra parenthesis there now. Yeah, now. Yeah, so I don't understand what the fuck is going on. Why is this broken? Can you put the first case? Oh no no no! You actually no, you can't. You can't put the second case as the first because of the catch-all. It will do bad stuff. Bad stuff. Man, what the fuck? Are we high? Like, come on. There's something wrong. There's something very wrong. We need to discover how to do the OR pattern properly. Could you put parentheses in wrapping the computer maybe? The parentheses wrapping the answer of the match. Yeah, there. I don't think that's the problem, but who knows? Yeah, that's not the problem. Man, doesn't OCaml doesn't allow for this? Are they kidding? Okay, for now, just copy paste the answer in both matches. Right, we can figure out our pattern later. Yeah, this doesn't make any sense.
Actually, we can do a catch-all here if we put this side condition. Actually, no, that doesn't quite work.
No, we have to keep it this way, man. I think let's keep it this way and put a to do. I can ask the FP Discord later. I don't understand why, but well. Anyway, let's go back to where we're. Oh, we have to fix everywhere that is using the bind now. Okay, let's do that. Search for bind and let's fix the places that are using it. This is a reference. Both are references. Done. There's an optimization that we can do here. Line 111. Do a underscore in the address and then rename it, pick the entire reference. So then we don't have to reconstruct it later. Reference. And then you just use it down there. I think that's it. Next up. Man, we are doing something very bold right now. No, let's skip this one. This one is what this is our main thread of thought. Let's go to the next
This should already work actually.
one. That's true, but let's go to the next bind.
It's this one.
Do we need
Which
the
is
address? The answer is no, so fuck it. But I need to create something. Actually, you already have a reference with the H register. How convenient.
We also have the dereft cell actually, so we can just say dereft cell reference, and we don't need this anymore, right?
That's completely fine. Cool. Okay, now we can go back to what the heck we were doing before. That's not
it. Which is this one.
Okay. So if we do a match on D1 and D2, if one of them is a reference, if either of them is a reference, we do the loop with the bind. If they are both constants, we just check if they are the same. If we have functors, we need to do all of these shenanigans here, and we are doing PDL manipulations on there.
Actually, this doesn't quite work because deref cell will never return a functor. It will return a structure actually.
So let's change 173.
Yeah, so we need to do something like structure A1, structure A2, and then we need to do a match A1, actually dref
A1
A1 store dref A2 store
with
with, and
genius.
basically it's not this.
Yeah, something else is fucked.
Actually, not this.
It's still not happy about it. You need another control. Yeah, you need another control now. Yeah, copy this one. Copy the 191 and then indent one less.
Actually, the catch-all for this one should fail, because if we ever have a structure pointing at something that's not a functor, that's obviously a memory corruption.
Okay, so let's put fail with then. Yeah, that's not it. You need to do a ident one less.
Fail with
Unreachable unify. Our first unreachable for unify.
unreachable unify structure points at non-functor.
Yeah, but we're still missing another catch-all. Oh, are we? No, we're not. Actually, that got fixed. Okay, what are they mad here?
This pattern matches values of type cell. But dref.
Oh, this returns an
Oh,
address.
this returns an address. Why does this return an address? Why does this return an address? This should actually be. Oh, I know why. It's because this is for the. This is not what I want. What I want is actually store get. And the
The star
arguments are
comes first.
flipped.
Yeah, you
Store
want the store get.
get store a2. This can go away.
Perfect. Now we go back to the PDL problem.
But then we have these, but actually we can just do d1, d2, no? Oh,
No,
actually we can't.
we
We
are
can't.
folding, friend. We're actually
Well, but in this
folding.
case, well, but actually in this case, we know that d1 is the structure with address a1, right?
That is true.
So we can, just
A1 and
do
A2.
a1 and a2.
Genius.
Should these be addresses though?
I'm actually a little concerned. Can you grab for this address? I think we're getting out. Wait. Okay,
We
we are
use
not
addresses
getting.
in,
Yeah, we
yeah,
are
no, we
using
use
addresses
addresses,
everywhere.
but we use them internally though, for things that shouldn't appear as values normally.
Okay, but in this case, what should we do?
Let's see. Since we're doing since this is going to be a P1 and a P2, this should actually be a reference, not an address.
Man, you're doing very bold maneuvers today.
Otherwise, we will have to special case this match to deal with addresses, but addresses are not actual values in the language,
No, but
so
that's what I'm talking about. We are using addresses somewhere else, right?
we are using them for return addresses and for other stuff. I don't remember what exactly
Exactly, that's the
off the
problem.
top of
How
my
do we
head.
know that they are we were implicitly holding onto the assumption of the pop on line 164 and 165 popping addresses and addresses being
Oh,
used somewhere else.
oh, this is easy actually. It's because for the PDL specifically, the only place that we push is in Unify.
Okay. Okay, so let's just see. Well, compiler system development, right? So let's just see why the compiler breaks now.
Okay. Um, oh, we forgot one Unify actually.
That makes sense.
Here.
Easy enough. Grab the reference, pass in the first one, and then the second you need to wrap. Okay, that's good. Aha!
Get
Get
value.
value is also now fucked.
Except we can just do this, no? Like,
Yeah, actually. Well, not really, because if we do the way that you're saying, we're gonna miss the fail width in 612 there, and that sounds
we are
pretty
not,
important to me.
we don't care about that actually because we're getting rid of this pattern matching entirely.
Okay.
Um,
There's a missing parenthesis somewhere. Yeah.
well,
Okay, let's go for it.
okay, that's the same result we had before. Let's try a program that we know works. So let's try factorial. Why not? Right?
Oh, we are trying to see if. Oh man,
If we
I'm
broke
scared.
anything,
I'm
yeah.
scared. Ah, we broke something.
But data
Fuck
isn't a
me.
functor.
Fuck me. I hate that. I hate
Mm,
that. We were responsible when we make a test suit. So now we have to fix.
actually, we know where this is breaking. It's it's in this new one. Right. So what happened? We have A1 and
We
A2.
did a get on stuff that is coming from structures, and they are throwing it to us things that are not functors.
Yeah, that means factorial try me else get structure. That's the argument handling. That's inside factorial 3. Let's do something here. Factorial. Let's put debug.
Man, can we try to run a simpler program like the plus or the multiply? Because factorial is gigantic. Okay, so
Yeah, plus
multiply.
doesn't break. I'm guessing this doesn't break either.
I'm guessing this does. Yes.
Oh, it does.
Because
Okay.
factorial is multiplying this guys anyway.
Okay, so multiply. We
It's the same
fail
place.
when we call multiply 3 and we're handling the arguments in this case, right? No, this case actually. Yeah, that's a try me else. Which means we should
Debugging line 10.
debug in line 10, yes. Debug. And we didn't hit line 10 apparently.
Um.
Multiply 3.
Oh, it's actually on the multiply 3.
Yeah, not multiply 4.
So that means that is a query thing.
No, it's after the call.
No, yes, it is after the call, but it is immediately after we are done with doing the query stuff on 17. We
Yeah.
go to line 8 and there we fail.
Hmm.
Isn't it easier to just go to the unreachable and put a pattern and put a print on whatever the gets are getting? Oh, okay, the formatter changed everything. Yeah, just pattern match on the what? Man, what the fuck happened?
What do you mean?
The call. Oh, this is the get structure. Okay.
Yeah,
I
it's not unify. It's get structure actually that's breaking.
let's print the value. Yeah, let's print the value.
Fail with blah blah blah. Pointer is a structure pointer, and then actually we need to
Yeah, I don't know how to do that. You have to do
data.
Yeah, string interpolation there.
Um, cell dot show, right? Value.
Yeah. Yeah, but the value is not. What is the value is a. Yeah, that's true. Okay, let's see. Run it.
Data isn't, well, clearly it is a functor though.
Ah, but it is
Oh,
a
I
functor that
see.
doesn't matches the shit.
Oh, I see. Yeah, no, this should actually fail and not
Fail, fail.
not blow up. Yeah.
Well, let's put another case there. Yeah, functor, whatever, whatever.
Functor underscore, then we
Copy line
return.
136.
Actually, you should copy this. Yeah.
There we go. Go for it. Okay, now we are reaching the stuff. That's gonna take a while. Just ask it to leave it. Like let it fly.
Um,
I forgot how to do that. Toggle debug mode. Q. Okay.
it ran. It worked.
Run the
We got
factorial
almost.
now. Man, that Discord is fucked, Nathan. Okay.
What
Let's
is
run
Nathan
factorial.
saying? That's an interesting font. That's an interesting font. What do you mean? It's Yosevka.
Did you check the print?
Oh, right. There's a bunch of vertical lines. Yeah, something's wrong on the transmission apparently.
Yeah, to me it's completely fine. Factorial time.
Actually, there's one thing though. Before I'm not in text mode apparently.
Ah,
Can
you
I
should
change
do
that?
that. Yes, you can change that somewhere. I don't know where in the new interface, but you can change it.
Um, change string quality, frame rate, resolution, more options. Can we do? Can we do?
It's inside the cog probably.
There we go. I found it. There.
Yeah, it's way better. It's way crisper. Holy fuck. Okay, anyway, run the factorial. Let's see if we didn't break the most advanced example. Enter angular numbers for that for good measure as well. Okay, that seems correct. And I'm not gonna count that. So, good luck. I don't know what triangular is running, but this seems correct. Okay, let's run the test program now. This is
Yeah, it's
4.
triangular of 4, which is 10. That is correct.
3, 3. Yeah, that's correct. Okay, let's run the test program now.
Mm,
So what are we expecting for the test program? I don't actually have no idea. 0.
this should succeed and bind A to 0. Yeah.
Well, actually this is show nothing because the query is asking nothing.
Oh, right.
You should
That is
change one of
correct.
the zeros to B.
Unreachable unify value. Amazing.
Yeah. So let's go there. So we have something that is on our reference. We have a number. Of course. Of course. That makes sense. We need to care about numbers now.
Do we actually need to do anything special here? Can't we just
Do
um
the get register directly into the Unify?
yeah.
Sure. Why not? You read my mind, Marinho. You read my mind. One
And
less
now we
unreachable.
don't need, yeah, we don't need this.
Perfect. Go for it. Oh, no, no. Before you go for it, go to the example and change one of the zeros to B.
Uh, Actually, before that, okay, that works. And then in the example, change one of the zeros to B.
Run it.
B0.
Damn. Okay, now let's go to the plus program and try to use the integer predicate, built-in, primitive, whatever.
Okay, where do you want to do that? Here?
That's yeah, why not?
Uh,
No, 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 wait. That's not gonna work.
let's yeah, let's avoid that. Let's do this workaround. Why not?
No, 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 no,
This
but
is
this is not gonna. Okay, that's actually gonna work because of the unwrapping. Okay, go for it.
um, main. It should be plus, right?
Yeah, can you go back to the example? Let me.
Yeah,
Well,
that runs.
well, that runs, but now I have a question. Can't we just? Why do we need the true though?
To avoid the problem that we still haven't fixed when int is a tail call.
Oh, okay, that makes total sense. Let's fix that now, because are we done? What else do we have to test to see if leech numbers are working? Aside from this problem.
That's basically it, actually. We should probably commit what we have first because we did
Definitely.
a major change and this
Yeah,
looks
no,
stable.
yeah, no, we did very bold, like, grown up with balls move here. Because we
Okay,
essentially changed the semantics that unify doesn't work anymore only on addresses, it works on everything else.
it works on cells.
Which is essentially everything else.
Yeah, it works on anything that's a cell that has the size of an address.
Okay, let's commit. I think we did great. Did great job. This was actually a little less threatening than what I was expecting, to be honest. I was expecting to be
Make
way
unify
worse.
work on cells, right?
Yeah, pretty much.
So they can hand. Oh, so it can handle
Constants.
constants.
And that's gonna actually save our asses when we actually introduce lists, for example, right? And strings.
Yeah,
Cool.
let's push.
Okay, if this is everything, we have another hour. So let's fix the other tail call problem.
Yeah, let's fix that. Okay, so basically, yeah, code generator 335 corner case. Let's fix this. So here's the problem. The problem, actually, there are two problems. Problem number one, we are assuming that um, when we finish this fold, which is emitting the code for
It's because
this one,
int is a primitive, which means that we don't do a call.
int is not a call instruction. Yeah,
That's that makes total sense. Like we are doing a call that is not like an external call. It's an internal call. So an internal calls that they don't appear here.
yeah, that's the first problem. But here's the second problem, actually. The second problem, yeah, this is basically just switching the call to an execute, so we have tail calls. But the second problem is we need to actually add proceed afterwards if we have a tail call to an instruction instead of actual call. Um, and the reason for that is because we're going to run the instruction and then we should return, but the instruction doesn't return by itself.
Okay, I have a
And normally
proposal.
this would be a tail call, right? Which is a jump.
Yeah, I have a proposal. Go to machine.ml
Machine ML. What's the
Yeah,
proposal?
go to the cells on the top. Yeah. So my suggestion is instead of having the is integer on 29 being mixed with everything else, why not we create an instruction called built-in, and then the built-in has the is integer and everything else, and then we pattern match on the built-ins on the code generator, so we can handle this. Oh, this should be a proceed, and so on and so forth, because
Mm-hmm.
otherwise we're going to have to do this treatment for a bunch of built-ins in the future, right?
Sounds fair.
Yeah, there is a problem with this strategy though, because changing the is integer from here will break everything. If you put
Um,
another layer of nesting, which is I'm proposing built-in, then everything is going to be fucked, and we're going to have to redo it.
uh, okay, what if we do a compromise, okay? Instead of saying, okay, built-in, and then we have a bunch of nested
Options in there.
instructions in the built-in,
Yeah.
what if instead we just define a predicate, is built-in or something like that, that returns true for these two but nothing else?
That sounds fair. It's a little bit less organized because it's not immediately obvious when reading the code. But I'm trying to assess, is this compromise gonna bite us in the butt in the future? What are we losing by doing this way instead of what I said? Aside from readability.
Mm, aside from readability.
You can always start using GADTs. I don't know how GADTs would solve our problem in here. Actually, GADTs would just be what I said, but in a different way. So, what do you say, Marie?
Let's try your way first and see what breaks. Because that will tell us, okay, which is actually the best way forward, right? We need to see how much breaks
Well,
first.
I don't think it's gonna be a lot,
Probably
actually.
not, to be fair.
Yeah, let's introduce a built-in. I think that's better. But here's a kicker. You're proposing to make debug a built-in. I'm not 100% sold on that because debug isn't a built-in. That's a developer-only thing.
But it's, well,
Like users of
that's not
Karuta will be using is integer, but they won't be
okay.
using debug.
No, 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 no. But it is a built-in because it's basically it's an instruction pretending to be a predicate, right?
Yes.
That's the definition of built-in we're going with,
Okay then.
which fits in this case.
Okay then.
Lemons.
Go for it.
So if you had the JDT, it would still be quote unquote flat, right? It would still be on the same position. But on the types, you could distinguish between them. Oh, yeah, not sure how that helps in the pattern match indeed. Mm, yeah, maybe it doesn't help. Only if you want functions that only accept a
Yeah,
subset of your compiler.
exactly. That's kind of what we're going
Yeah.
for here. Yeah. Yeah, I'm very fine with this. Okay, what do you want to do first? Do you want to fix what everything is fucked, or do you want to? Okay, let's fix what everywhere that is fucked. Okay.
Line 50. Line 50.
No, of course. It's because we don't have these options here anymore.
Add instruction.
You need to add the built-in on 48, 49. You need to add the wrap those things with built-ins now.
Right, that is true. So let's do that. Cell dot built-in.
You don't need parentheses on this one probably, but in this one you would. But you can use at.
I can't actually.
Oh, it's because these are not fun. Oh, you need to put the ppx, man. I keep forgetting to put the fucking ppx. Okay, now, whoa, actually it already worked. Evaluator time.
Is there a PPX to use the tags as functions?
Yes.
But as in they introduce a function on the scope
Yes,
that
it introduces the functions with the same name as the constructors, but well, non-capital letters, right?
oh okay.
Yeah, fixed. that didn't take a long time. Okay, so now let's fix the problem. So now we have the ability to nest stuff.
Uh,
Cool. Uh, so I have a
we should
proposal already.
actually we should probably commit this first, right?
Yeah, go for it.
Mm, add instruction category for built-ins.
Nice. I have a proposal. Go to the line that is breaking. Um, Instead of doing this, let's do a match on the code get, and then we can do the shenanigans.
And then we can do the shenanigans. Okay. Okay, so basically, what do we need to do? What do we need to do? If
We're
we
gonna do two
get
matches. Well, we're gonna do three matches. We're gonna do this one, and then do whatever we're already doing. We're gonna do the built-ins, and we're gonna have a catch-all for unreachable.
yeah, okay. Let's see.
That's it. That's exactly it, actually. Perfect.
Okay, so match with an A, if I can spell.
Match on this, and then
With,
with, and then the first match is this thing. Doesn't need parentheses, by the way. Then there we go.
let's put this here just for the sake of making our lives easier for now. And then
We're gonna have a catch-all with unreachable. And then we're gonna also have e built-in. And then we're gonna do the thing. So for now, it doesn't matter which built-in we have, right? Because it's always gonna be. For now,
it should
it's
never
always
matter.
integer.
It should never matter, actually.
Oh, okay. So now let's just basically copy paste lines 337 all the way to 342, but swapping the execute and things like that.
To do just so the formatter can run. Okay, so what do we need to do? We need to do basically the same thing, except there are two
Proceed.
differences. Um, one moment.
Sure.
If the previous p register is a call, we add an execute and we replace the previous p register with a deallocate.
Yeah.
What we should do instead is just push. We need to do a deallocate and a proceed. Actually, that's what we need to do.
Why do we need to do a deallocate?
Actually, do we? We know the last instruction will be a call because of the fold, corner case being debug. Yeah, if the previous P register is a built-in, then yeah, we need to do deallocate and proceed.
Why do you need to do the deallocate? Oh, because you're taking a calling, which means we can get rid of everything from before and just proceed because this is a built-in and not an execute because we're not doing a call.
Yeah.
Perfect.
Okay, so basically what we do is
Just
we
copy
actually don't
paste.
care.
Yeah, copy paste the code. Yeah, copy paste this code. But instead
Yeah,
of the
except
execute, we do proceed.
we do a deallocate first.
It doesn't receive anything. Yeah.
And then we do a proceed. We don't need this, which means we just need the put allocator. Is that it? There's no constructor built
Oh,
in
it's
with
cell dot
machine
built-in, my friend.
cell. Alright, it's cell.instruction. And this needs to be a cell.built-in, and we don't care about what's inside of it.
Let's try to run.
Fail with. Do we keep this impossible here?
No, we should probably keep it. Well,
No, I mean the message. We're keeping
uh,
the fail with for sure.
the message should be something like unreachable.
Something went very wrong when generating a tail call.
Yeah, that's good enough. Okay, let's run the program.
There we go.
Which program are we running here?
We're running. Oops. We're running plus.
And what? Let's go to there. And this is doing 4 plus 2, which is
This
36.
is doing, which is 6, yeah.
Okay. Damn, you can remove the two to-dos there.
But now we can actually do something very silly. We can do 42 here and 42 here.
No, don't do. Actually, yeah, that didn't work so well.
Oh, right, because our base case is 0. We're never gonna reach it. That makes sense. That makes perfect sense, actually.
Yeah, no.
Oh well.
You tried to be clever, it didn't work. uh, okay, we have another half an hour, but I think I'm gonna call it because people are getting mad at me because I need to leave. So just remove the two to-dos and let's do a commit and let's call it.
Okay. We did good progress today.
There is something up there in the example that I'm a little bit suspicious. Can you go back to the diff? Yeah, you can remove that debug from there.
I'm not gonna commit
Oh,
this
debug
anyway.
also debug also works on tail call now.
It should, yes. Let's go to plus real quick and just double check that, right?
Yeah.
Debug.
Wait, but that doesn't make sense, right? Because debug, what is the semantics of having natural depending on debug?
It's always going to succeed, except we have a chance to inspect the machine. Like,
No. Press Q now
declare,
then.
press Q.
Yeah. Go. You're right. Debug always succeeds.
Yeah, debug is basically true, except it's a developer hook. It's
Yeah.
true, but it's a developer hook.
Yeah, you can change this back to int from before, but well, check if you removed from the previous program.
Uh, we're not gonna commit any of those though, right? Because we are just changing this to check stuff, basically. The semantically correct value here is just 0, right?
I want a program. I want a test program that tests int. Put 0 there. Why not?
Okay. There we go.
Okay, so now you can commit.
Where is the int?
Good question.
Ah, too many instructions. Let's not look for it. Oh no, it's here actually.
Yeah.
That was easier than I thought it would be.
Don't blame us, Nathan. Blame the book. I have nothing else to say.
Fix corner case where we call built-in
In
in
tail
tail
call.
position.
Yeah, in tail position.
Let's just say tail call, that's shorter, and it means the same thing.
Nice. Okay, now the question, the real question. Are we gonna add more? What other literals are we gonna add in this branch? Are we gonna add more literals in this branch?
We probably should add.
We should add operations on on integers, no?
We should, yes. We should add operations on integers for sure.
Okay.
Should we add strings as well?
Well, I guess that's a very controversial question because what are we gonna use as the internal representation for strings? Are we gonna allow
Well,
pattern matching on strings?
well, we can go the Prolog way. Actually, Erlang does the same thing, I think. Actually, does Prolog do this? I'm not sure. I know Erlang says, okay, string is really just a list of numbers.
Yeah, but that's what
That's all it
everybody
is.
hates about it.
Hmm,
Like my problem with not going with strings as lists is the fact that you lose powerful functionality such as being able to pattern match and being able to use list manipulation functions on it. I understand that we all have problems with performance on strings being done like that. I understand. However, if we're not gonna do that, we're gonna have to kick butt with the prelude for strings.
yeah, yeah, that is true. Hmm. Well, we can discuss this on the next session, but yeah, in terms of just implementation ease, we probably can do like list of numbers.
Oh, there is something that I wanted to today before we finish.
Okay.
Let's add the alias that allows you to do debug without brackets. So
That's not really an alias, but okay. That's a parser thing,
that's a
actually.
parser thing. That's a
Yeah,
parser thing.
yeah. Here's the problem. We always parse the left delimiter here in this functor case, right? We shouldn't actually.
No, we should, but there should be functor left right immediately. The left and the right immediately one after each other. Then we can catch that and do something about it.
No, no, no. But this is a saying. Okay, if we have a left delimiter after an indent, then it needs to have a list of identifiers, right? What we need to do is say, okay, an indent without a left delimiter should also be a valid functor.
Oh, you're right. I was saying bullshit. You're right. Can we do that?
Can we do that? The naive way doesn't work because it's ambiguous, right? If you just do functor name equals ident and then try to do stuff, yeah, this is overlapping, right?
Well, we need to say that there is something coming that is not an ident. Not ident. I left the limb.
Do we have negation in this parser generator thingy in main here?
That's a good question. Let's search. Well, Nathan should know. Oh, right. You don't actually need to search in the same browser because you have another monitor now.
What should I know about?
We want to know that if you can do negation on the. You see line 28 there?
In sure.
We want to say that. We want to say exactly line 28, but instead of left the limb, we want to negate left the limb.
I'm not sure if there's a built-in way to do that, but yeah, that's not something I ever looked into.
Okay.
Okay, there's a question about this in here.
What is the
Let me
answer?
put. I'm still reading it. Hmm.
Okay, adding heck to Elixir.
Hmm. Man, this is why we should always use peg parsing.
Oh man,
like
that's too late for that.
like context-free grammars, those are for chumps.
How do you negate stuff?
Technically, well, the technical term for what we want is a negative look ahead, basically. But yeah, that's I don't think. Hmm, yeah, that's not really part of the formalism of context-free grammars. Actually, it's not even in. Well, yeah, it's not in context-free grammars, unfortunately. It's also. Yeah, this is. Man, this is kind of annoying.
Well, I would
Can
say
we
then let's.
actually can we make this like can we make this optional? Like this to this?
Well, I don't know how that works. Actually. So if you say that that's optional, well, is that the way to do it? Is that how you do that?
I mean, that would be there should be a way to do optionality, right? Let's see. Man
Optional.
here optional. Man here optional.
Oh, you actually write option. Is that it? Is that?
Option.
No. That's bullshit. I think that I'm reading the wrong thing. Optional main here OCaml. No, it exists. Wait, what? Yeah, it is called option. Okay. Yeah, man. Yeah, that's it. You just write option there.
You
You
mean
wrap
like
every Yeah, you wrap everything with option.
t equals option blah blah blah.
But now I have a question. What's gonna be the type of list identifiers? You know? Oh,
It would have to be something like this, right?
An option?
maybe.
uh we can't do pattern matching here, can we?
We should.
Don't you get the whole identifiers thing as an option with the things inside?
Yeah, that's what we want to get rid of. Like patch sum and then v.
I mean, they still will have to follow, right?
Yes, still have to follow. No, that's exactly what we're trying to not do. Can we do any OCaml in this thing? I think we should be able to. Just continue doing
You
what you're
are
doing,
doing.
Maninho. I think it's gonna work.
uh,
Oh, you mean as in empty list when
Yeah,
you have the.
yeah.
Oh.
match identifiers with
Sum,
it's
sum.
some. This is shadowing, but it's fine.
In Haskell, you would have a function for that, right?
I don't know what you mean, but sure.
You certainly have
As.
functions for things you don't want. Oh, probably.
Huh?
In Haskell, you even have functions for things there shouldn't be functions.
Yeah, those specific transformations between options and lists.
Ah, oh yeah. Yeah, but OCaml probably has one
Yeah,
of those.
there is one. It's option of list, right?
Oh, that function exists? That's what you're saying?
Well, it exists in F sharp and SML. If it doesn't exist in OCaml, that's cringe.
Well, but OCaml doesn't have many shits about.
Well, but the fact that it doesn't have an
Oh, there
SML does.
is. There is. Oh, but there's only a two list. I want to
Yeah,
come from
convert.
list, right?
Oh, then
No,
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 no, no, no,
you
no,
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 want
no.
no,
We
we
option to
want.
no, we
list,
want this
right?
case. No, no, no.
List of
Magenta is
option.
right.
Does it
It is an
exist?
option. So it is option dot to list, Marinho.
Option dot to list.
Do a let instead of a match, and then just use it.
Let's
Let
identifiers
equal
equal option dot
dot to list,
to list
and then
of
you pass
identifiers
the identifiers, and then you just use one thing instead of having twice.
in. Yeah, this is way better. This is way better.
Yeah, assuming this works. Assuming this is how
Assuming this
party
works,
works.
yeah. Assuming this works, it should be great. Uh,
Okay, let's see.
That was a
Let's see what.
Kakun regex, wasn't it? The formatting.
That's
yeah,
not.
that's not what I wanted. This.
Yeah, it's fucked. Syntax error after list identifiers and before
Oh, there's a.
parentheses.
Oh no.
How do you do optionals? Is that how you do optionals? Come on. Option?
Isn't the parentheses wrong? They're
Where?
on line 32. Oh no, it
32.
closes and you guys type, right? So you guys are casting. No, that is seems correct. So closes there.
Remove the semicolon in there.
After list identifiers and before. Okay.
I don't think that does. Yeah, I don't think that does it. How do you use option for main here? Come on.
What do you guys want? I don't
We
follow.
want to we want to allow you to write a functor with zero
Oh, okay.
arity
This is the
without.
parser. Just notice now. I
Yeah.
see. Okay.
So what we want to do is on line 28 we want to say okay you can have an identifier but you optionally have these other shit. We want that's it. And then if that's the case we can do the zero arity for you instead of having to do open and close brackets yourself.
Is this option
Uh,
thing kind of like a function as you are kind of using line 37? If it
Let me
is,
show
then
Marinho, look at this link, man. See if I'm tripping balls.
Can't we just do like apparently this works, so can't we just do like if we go back all the way to
option is a single guy, right? You can do with multiple. Can you?
if we go
Actually,
back all the way
can,
to
but
here and we
you need to define as a
say
new rule.
name f functor name, that's an AST functor, right?
Yeah.
No, it's an AST func
Funk.
apparently.
Yeah, funk.
Thank you, man. Here. Yeah. So you will need to break down to a new rule and use the option on a single guy for multiple terms. That's strange.
I mean, if expression works, then this should work, right? If we do functor name equals ident, and even though this is ambiguous, right?
Yeah, this is ambiguous.
And then we do
Wait, so
this.
your suggestion is to make it ambiguous then?
Uh, well, it's already ambiguous because of this, right?
Because of that.
Well, my suggestion is to make it more ambiguous, I guess, I suppose.
I don't see why this is ambiguous at all. I don't see why this is ambiguous at all. Yeah, this is that was not ambiguous because that rule that you removed that was counting on the right delim, which is on line 47. That's different. That's different than what we're doing now. I think we should try to
That's,
pursue the option thing.
that's not what I wanted. This. Please do not say. Okay. Okay. Unbound value name f. Unbound value name f. What do you mean?
You need to this is a type, man. You need to say which type it is, I think. But I think the option was better, Marie. I think I prefer that one at least.
That works, apparently.
No, it works, but it's worse.
Why?
Well, because of what I said. The rule that you removed from expression was counting on having the right delim. By removing from there and adding here, now it's ambiguous.
It was counting? No, it wasn't actually.
It was, because this is an expression. And the expression rules depend on the list identifiers, because that's the only places that we are using expressions. And the list identifier says that
No,
it
no, no,
must have a
that's
comma and a right delim.
no, that's backwards, Lemos.
What? I'm
Look, a
extremely confused now.
list identifiers is used inside of functor, right?
Yeah, and the only place where expressions are being used are in list identifiers, correct?
Uh, that is correct,
So
yes.
expression must have a comma or a right delim there, which
No,
made it unambiguous.
no, it doesn't have to. The right limit is already here.
What?
It's outside of the expression, Lemos.
Okay, I'm gonna try to rephrase it because I think you got lost in what I said. If you pick the rule from line 30 and you put back on the expression as it was before, that was not ambiguous, the previous grammar, right?
It was. Was it? Actually, no, it was. What
How?
makes it ambiguous? Because, okay, if you have an ident here, right? How do you know if it is an ident for a functor without a name or a functor with two R's? Because this is also going to expand to an ident and a left the limb, right?
Yeah.
Hmm.
Oh, I see what you're saying. You're saying that the previous case was ambiguous, and we knew that. That's why the ident came after the functor.
Okay, actually, no. Now that I think about it, this is not ambiguous because we don't have lists, right? So actually, this is the only place where the left delimiter can appear.
Okay, so this works. Well, we know this works, right? So let's remove brackets from some debug somewhere and see if that works.
Okay, debug.
No, no,
We
no,
have a
no.
debug
Not
somewhere.
not these debugs. We need to go to a program. Yeah. Run and don't forget to change the program to be multiply.
Yeah, that works.
Q.
I'm on the debug.
Okay. Can you explain again why the grammar is not ambiguous? Because to
Because we
me
don't
this
have.
is ambiguous.
It's because we don't have lists, Lemos.
No, no, no. But
Because here's the thing. The only place where a left delimiter can appear is after an ident, right?
yes.
Um, that means. That means. Actually, it wouldn't be ambiguous even if we had lists because of the commas, in fact.
Wait, I'm not following you. Could you elaborate?
Because this is not a list. We don't separate expressions just by white space, right?
Yeah.
That means if we see an ident, then either it must be followed by a left delimiter
Or not?
or not. But if it's not, then it cannot be followed by a left delimiter because you can't have an atom and then a list without a comma in between. That's invalid syntax.
Mm. I think I see. Can we test to see if the brackets, using the brackets, if you want to use the brackets for whatever reasons, if that still works?
Sure.
because I just want to extend them. I don't want to remove them.
Still works, just the same. But actually, we should be able to do this as well now.
Yeah. Now that you think about it, yeah.
It still works. Amazing. It's amazing.
Okay, so the reason it's not ambiguous is because you cannot have a left delim in any case aside from an identifier coming immediately before it.
Yeah. And even if you could, it would have to be preceded by either another left limb or a comma.
That's
Like
fine.
there's no possible ambiguity where okay, I have an ident, I have a left limb. Is that an atom in a list or just a functor with arguments, right? That ambiguity is never gonna arise because of how the rest of the grammar is laid out.
Okay, so I got it. Okay, I understand. Okay, let's commit that and call it a day.
Okay.
I wanted to do this for some time. Very glad the change was easy to do.
We can put this down here, right? And it
You
should
should.
still work.
You
Okay.
should.
Make brackets optional on atoms.
Well, I have to go now.
All
Well,
right.
I'm very happy for today. I'm gonna finish the recording first.